In this video, we'll look at a non-standard linear programming problem where we include artificial variables alongside slack and surplus variables. The procedure is exactly the same as other non-standard problems, except when we have artificial variables included, we have to be a bit more careful. So here's our problem. Notice it's a non-standard linear programming problem. We want to minimize this objective function. We've got our constraints, our mixed constraints, mixed inequalities, with the added equality constraint. Okay, so this is what makes this a little bit more complicated than the things we've talked about before. Now, because this is an equality constraint, it's really a constraint. We have to make this different than the actual objective function, which is why we add some extra variable, the artificial variable. Okay? Now, notice also that we want to minimize, so instead of calling my variables x's, I call them y's, just to be consistent with what we've talked about before, and to differentiate this from the corresponding maximum problem. Now, the thing about it is, when we want to deal with this kind of non-standard linear programming problem, the standard procedure is to work with a maximum problem, because maximum problems are easier to work with in general than minimum problems. Okay? So the natural thing to do is, if it really is a minimum problem, let's just convert it to a maximum problem, and then at the very end we have to convert back. Okay? So the first step is to convert this to a maximum problem. Well, in this particular type of problem, when we're dealing with the non-standard case, we can't just use duality like we used before in the standard case, because we have mixed constraints. And so instead, we just have to come up with an objective function that is really a maximum. We want to maximize it rather than minimize it. It's pretty straightforward. The thing about it is, in order to change this to a maximum problem, a corresponding maximum non-standard problem, all we have to do is change the objective function and none of the constraints. All of the constraints will be exactly the same. Okay? So notice that if I change w to a minus w, that would be my z. Right? So in other words, if I'm going to minimize w, I should maximize minus w. That kind of makes sense if you think about it. So therefore, the corresponding objective function to maximize would be minus w. So instead of working with w, I'd rather work with z. Okay, this is just a general procedure because it turns out to make things easier. Okay, so let's convert this to a maximum problem. It's pretty easy. All we're going to do is leave all the constraints exactly the same, and we're going to instead maximize minus w. Okay, so minus w, which is now my new z. So z is minus w. So I just negate all of these. So it's minus 15, minus 12y, and minus 18y3. Okay, so I want to maximize minus w, or I'll call that z. Maximize this z subject to the exact same constraints. Okay, so I've just converted to a maximization problem, and we can go ahead and now add our slack, surplus, and artificial variables, and then finally be able to convert it into a tableau to work with. So now I've written the constraints down, again, with my z that I want to maximize. Again, z is minus w. Okay? So again, what I want to do is add the slack and surplus variables to all of these. So again, to make them all equalities. So what I'm going to do is, for the first one, I'm going to add a slack variable, because this is less than 12, less than or equal to 12. Add something to it appropriately to make it exactly equal to 12. So I'm going to add a plus s1 for the slack variable. So then it becomes, of course, an equal sign here, so equal to 12. Similarly, down here, I have to add a surplus variable, because this side is bigger than 18. I got to subtract just enough to make it equal to 18. So minus s2. That's my surplus variable. And finally, down in the third case, I want to differentiate this from the actual objective function. So I have to add something to this called an artificial variable. Okay, so I'll call this a1. There's only one of them, so I'll just call it a1. So that's my artificial variable, my surplus, and my slack variable. Add it all to make these all equality constraints. And finally, the z, as usual, I want to solve this for 0. Okay? So I should rewrite this as 15y1 plus 12y2 plus 18y3 plus z is 0. Okay, so that's my equation corresponding to the objective function. Okay, So now let's go ahead and put this into the usual tableau, and I can perform operations on it. So now I've written the corresponding tableau for the problem that we started with, for this non-standard linear programming problem. Okay, it's the same kind of tableau that we've had before for other non-standard problems. The only difference is we have this extra column, A1, corresponding to an artificial variable. Okay? Now the procedure is exactly the same also, except we want to make sure that this artificial variable, that is all artificial variables actually, should be non-basic. Okay? Basic meaning that everything else in the column is 0 except for one entry. Okay? You can see that right now it is a basic variable. So for us to get to the first corner point, we want to make sure that all of the artificial variables are non-basic. Okay? In other words, something else in this column has to be non-zero. We have to perform some operations so that's true. And again, what makes this different than other non-standard problems is that has to be my first step. Okay? So the first step for this kind of problem is to make all of the artificial variables non-basic first. Okay? In this case, we only have one of them. Okay? So so that's what we have to do first. Okay? So the procedure is very similar to the procedure we used before to deal with the surplus variable. What I do is I take a look at what place in the column my artificial variable has the only non-zero value. There it is. Okay? And what I do is, as usual, I look in this one position and then I go as far to the left as possible. Okay, to the first column here, corresponding to that position there. Okay, so here's the position. I go all the way here. And now I want to use this right here as my pivot position. Because again, I have to be sure that A1 becomes non-basic before I do anything else. Okay, if it were non-basic to start with, no worries, and I don't have to worry about it. Okay, I just can go ahead and do other things. Deal with my surplus and my slack variable if I have to. But as long as this is basic right now, I have to make it non-basic first. Okay, make all of the artificial variables non-basic. Okay, so here it is. Here's my pivot position, and I notice that I have to pivot on this position. I don't have a choice. I don't have a choice here. And the reason why is any other location in this column would not make this a non-basic variable, right? I mean, if I pivot anywhere else, this is still going to be 1 and everything else will be 0. Okay? So I have to pivot here in this position. Hopefully you can see that. Okay, so my first pivot position is right here. Okay, so I'm going to do that first, and then I'll deal with my other variables as I have to, okay, as usual. So let's go ahead and do that. So this is my pivot, and what I want to do is I want to get everything else in this column, this first column, 0, except for that, of course, pivot position as usual. So here are the row operations. First of all, I'm going to let row 1 has to be 0. So row 1 is going to be replaced by row 1 minus row 3. Right? This is row 3, and I just subtract the 2 and I get a 0 there. 1 minus 1 is 0. Row 2 also has to be manipulated. So row 2 should be exchanged with itself, row 2 minus 3 times row 3. Okay, you see that? Because 3 minus 3 times this would be 0. And similarly for the last one, R4. So R4 is replaced by itself, R4, minus, well, look, 15 minus 15 times row 3, right? So 15 row 3, so that is a 0, okay? So these are the 3 corresponding row operations that I must perform in order to make everything else in this column 0, except for that, of course, pivot position, okay? Again, this is my pivot row, R3. So let's go ahead and do that, and I'll fill in the entire tableau with the information after I perform all these row operations.